Hello, warm wishes to everyone. Uh, Thanks for that another one opportunity to share the thoughts behind the concepts of self-organizing maps. So in previous episodes, we discussed that is the so many parameters related with uh, self-organizing maps. So before getting into the deep concept of that self-organizing map, just I want to give the glimpse and intro of the self-organizing maps. So the self-organizing maps or coherent map that's developed in that year of 1970s, and this self-organizing maps, this SOM is comes under the category of unsupervised learning. That's number one, and number two, by the clustering and it can able to implement the dimensional reduction also. So since this is working under the unsupervised learning, so there we are having the two set of methods. Either we have to be go for the classification, or we have to be go for that is that clustering. But this SOM, that is the self-organizing map, that's working under the method of that clustering, and also it provides the facility of that dimension reduction. Already we know what the dimension reduction is doing, so it can able to reduce the multidimensional data sets into the two-dimensional data, from that 3D to 2D, or that 4D to 3D, 2D, as well as from any dimensional data into the two-dimensional data. And it's also reduces the loss will occur when we have to be go for that reduction. So this is the core concept behind the self-organizing map, and then intro part of that self-organizing map. And one beautiful point is that this self-organizing map is an unsupervised neural algorithm based biological neural model. So this is also one variety of the biological neural model, just mimicking the brain, how that brain is working. The same way this self-organizing map is also working on the concepts. So this is also comes under the category of the neural networks. One simple statement I want to share with you. We know that is the variety of dimensional reduction algorithms. So the famous algorithm, it is called the principal component analysis, that is the PCA, and we know that is the linear discriminant analysis, and then so many dimensional reduction algorithms are available. But these algorithms cannot able to implement with the concepts of the neural networks, but that one and only algorithm can able to implement the dimension reduction in the setup of the neural networks is the self-organizing maps. In some time the questions may be asked in that different way. Please explain about the dimension reduction algorithms based on the neural networks. So if such a kind of the questions may be asked, so in that situation the only one answer you can able to be right is self-organizing map. This can able to implement the dimension reduction based on the concepts of the neural networks. So this is the core foundation of the self-organizing maps. Before ending of this first episode, just I want to give two types of primary layers that's available in that SOM. That is, number one is called that is the input layer, and number two is called that is the output layer. I hopefully believe these two layers already you hear when you thoroughly study about that is the neural networks, either in ANN, that is the artificial neural networks, or in convolution neural networks, that is the CNN, or you may with that RNN also. But RNN, it's having the little bit different, so since this is a recurrent, but it's also having the these two layers in all setup of neural networks. So from the basics of the perceptrons. So same way this SOM, that is the self-organized map, is also having the two layers. That is that number one is called that input layer, and number two is called that is that output layer. So in further episodes, we have to see how this SOM is working with neural networks.